So today we're going to go over function notation. So over the last couple days, we've been going over what a function is. For every output, there's one input. We talked about describing functions using the vocabulary, starting with linear, nonlinear. We talked about domain and range. Well, today the other aspect of function is called function notation. So make sure you guys list this in your notebook. Function notation, here's a basic definition. Function notation is a notation in which a function is named with the letter and the input is shown in parentheses after a function name. So for example, here on the screen I have y is equal to f of x. You can read it as y is equal f of x. Another way to read it is y is a function of x. And then the last way is y is depends on x. So all three of those ways are saying y is equal to f of x. But the most common way is really y is equal to f of x. In function notation, the parentheses does not mean multiplication. We'll see some examples of that. In this case, when you see f of x, it does not mean multiplication. So here we can see that a function, if I give you the function y is equal to 2x plus 4, let's break this down. This is very important. You probably have this in your summary aspect of your notes. A function, right away I know it's a function, f of x. Right here on the screen it says y is equal to 2x plus 4, and then I change it to f of x. Okay, those two things are kind of synonymous. They are pretty much the same thing, depending on what you're talking about. Y is equal to 2x plus 4. That could be a linear equation, and y equals mx plus b. F of the function f of x is equal to x plus 4. It just says that it's a function. So when I have f of 3 right here, f parentheses 3, remember it does not mean multiply. This could be read as function f of 3, function of 3. So all you have to do is, this is your input value, and I need to output it following the rule. So my f of 3 is equal to 2x plus 4. That's my rule. So what I'm going to do is I'm going to write f of 3. My input is 3. Whatever x is in my rule, I replace it with my new input value. So my input is 3. So my rule is 2. Instead of x, I'm going to say 3 times 3 plus 4. In this case, it does mean multiply because the rule says 2 times x plus 4. F of 3 is then equal to 6 plus 4. So when I have the function of 3, I get 10. And that's the correct answer. To get full credit for function and function notation, you have to write it in the form of f of, for example, if it's f of 3, you would say f of 3 is equal to 10. You just don't write x is equal to 10. You don't write f of x is equal to 10. You write f of 3 is equal to 10. Let me get rid of this purple right here. So functions can be also viewed as a function machine. If you have your survival kit, this is already in there. We'll talk more about function machine when you guys get back to class. But for example, here's my function, f of 3. And here is my rule. My rule is x squared plus 7. So what I'm going to do is I'm going to input f of 3, and wherever I see x in my function, I'm going to replace it with my input. So f of 3 is equal to 3 squared plus 7. So f of 3 is equal to 3 squared plus 7. I know 3 squared is 9 plus 7. So therefore f of 3 is equal to 9 plus 7. I get an output of 16. The correct way to write the answer is f of 3 in parentheses is equal to 16. And that's it. Input, output. Not all functions are equations. Sometimes you get a graph, and here's the equation they give you. Y is equal to f of x. I know that that is a function because one, they told me y is equal to f of x, or I can do the vertical line test and quickly tell that this passes and this is a function. Yes, you can do domain and range. Yes, you can describe the linear function. But what happens when you have over here f of 6? There's no equation for me to put it in. So I know that this right here is input. So when you have f of x earlier, that is the same thing. X is my input. So what I'm going to do, f of 6 is, I know that's input. Input can be viewed as independent variable or the x-axis. So all I have to do is go to the x-axis and see where f is 6, go to get my output. My output is 2. So when I have f of 6, my output is 2. That's it. Remember that x, independent variable, input, all mean the same in this case. Last question, for what x value or x values does f of x equals to 3? Now this one is a little bit more difficult because f of x, it says f of x is equal to 3. They give me the output. All I'm doing is translating what they said. They gave me the output. I need to find the input value that would give me 3. So I know this is the x-axis, I know this is the y-axis, but they give me the y-axis. My output is 3. So all I have to do in this case, go up to 1, 2, 3, go to where it hits the line, which is right there, go back down, and find that my input value is 6. So when f of x is equal to 3, x equals 6. Basically, f of 6 will give me an output of 3. This one is the reverse. Okay, one more time. F of x is equal to 3. Not f of 3, but f of x. So I need to find the x value that will give me output of 3, which is right there, which just gives me an order pair of input of 6, output of 3. And that's function notation. Make sure you list this in your notebook, and I will check it. Have a great day.